Hi, Algebra 2, Day 2 of Unit 4. We are going to start with the equation of a circle, and then we are going to move into what non-linear systems might look like. So if you remember, today's class, or yesterday's class, was really all about taking two lines and finding when they intersect each other. So now we're going to move beyond just linear equations, and we're going to look at quadratics and circles and lines as well, and see what happens when they overlap and how many times they might intersect each other. So go ahead and label your paper with the notes. 4.2, equation of a circle is topic 1, and then nonlinear systems is topic 2. So to start off, we need to know what the equation of a circle is. If you guys are doing Cornell note form, remember that the left side, we're trying to figure out what the major topics are. So I'm going to say, what is the equation of a circle? So the basic formula, the basic equation setup of a circle is we have an x value minus an h value, and we are going to square that value. So remember, when you square something, it kind of curves. Well, we need two squares because we need two halves of a circle. So we have x minus h squared, but then we also have y minus k squared. So when you guys think of the picture of a circle, we have a center of the circle, and then you have to know how big the circle is. Remember, from the center to the outside of the circle is called a radius. So what you guys have on the side here, it's equal to the radius squared. And I'm going to make a little note here. R is the radius. Okay? HK, just like when you guys were using the formula for a quadratic, the h and the k always told you whether to move right or left or up or down. And this is the same thing for a circle. Because the h is with the x, that tells you whether you're going to move to the right or to the left. We move right if it is negative, and we move left if h is positive. Then if you guys go over to the k value, because it's with the y, the k is going to tell you whether you move up or down. Again, it's always opposite when it's inside of the parentheses. So I would go up, or take a positive number if it is negative, and it would go down if it's positive. Okay? So again, anytime you have a value inside the parentheses, and then we're squaring it, we're talking about the opposite. So the radius is the r, and then the h comma k is the center of the circle. Okay? So when I look at my first example, I'm looking specifically at this number 1 here and 2. I want to write down what the center of my circle is. The center of my circle is the opposite of the numbers inside the parentheses. Remember, my x is with the x, and the y is with the y. So I'm going to take the opposite of negative 1, and I'm going to make that positive 1. The opposite of positive 2, and make that negative 2. So the center of my circle, the middle of my circle, is at 1, negative 2. Again, start from the origin, and I'm going to move right 1, and then down 2. And there is the center of my circle. It really doesn't matter if I have a center if I don't know how big to make my actual circle around the center. So I also need to know what my radius is. And notice how the equation, the formula says that the radius is squared on the right-hand side of the equal sign. So that means when I look at this 9, what number squared makes 9? So if I'm thinking about what number squared makes 9, what I really want to do is take the square root of 9, which is 3. So my radius is 3. Okay? And I don't know whether we're talking about centimeters or meters, so I'm just going to say 3 units. A radius is the distance from the center of the circle to the outside of the circle. So I need to count in all 4 directions from the center of my circle. I need to go 3 up, and then come back to the center of my circle, and I'm going to go 3 to the right. Come back to the center of my circle and go 3 down. Come back to the center and go 3 to the left. That will ensure that the center stays in the center and I have my radius coming out in all directions. And then, as best as we can, try to actually draw your circle by connecting your dots. Okay? And we can make a pretty decent looking circle when we have all those dots already drawn for us. I would highly suggest that you pause the video here, try number 2 on your own, all right, and then push play, and then you can listen to me. So again, I'm looking here at 3, and then there's no number. There's no number here with the y. So when I go to write my center, I'm going to take the opposite of the 3. So I'm going to take -3 for x, and there's no number for y. There's no number next to y. So again, no number in math means I'm using 0. My radius is the square root of 16, which equals 4. So my radius is 4 units. So I'm going to start with the center. Always start with the center. That's my starting point. My starting point is at -3, so I'm going to start at the origin, move left 3, and then 0. So I'm going to stop right there. My radius is 4 units. So from that center, I have to go 4 units in every direction. We go right off the graph. And again, as best as I can, I'm going to try to connect my dots. Okay? Now, this is the one graph that I would say you guys should feel pretty comfortable with graphing without a calculator. A circle, all you need to know is the center and the radius, and you've got it made. So this is the one graph that we should feel pretty comfortable, again, graphing without a calculator. So since our second part of the notes today is talking about systems, we need to consider some of the other graphs that we've already learned how to graph so that we can make a system by putting a bunch of different graphs that we're familiar with together. So again, this is review. This is review. And when we're graphing a quadratic equation in standard form, you can make a table, but we can also, easiest way is to grab the calculator and actually use the table in the calculator because it'll find it for us. So your choice. Again, I would highly recommend pausing the video here since you guys know how to graph parabolas, quadratic equations. You know how to graph them in both forms, standard and vertex form. So I would pause and try to graph these on your own, and then push play again and see how we did. So since this first one is in standard form, I'm going to grab my calculator, and I'm going to go ahead and put in my equation into y equals. Okay? So if I'm looking at my function, x squared minus 2x minus 3, I'm going to go ahead and put in x squared minus 2x minus 3. Go ahead and push graph. And I'm actually zoomed out, so remember I can always go to zoom and go down to standard, which is number 6. And it'll bring me back to -10 to +10 window. I have a picture, but I don't have exactly what my points are, so I want to make sure I go to my table. And my table, let's see. All right, that works. So -2, 5, -1, 0, 0, -3, and then 1, -4. So go ahead and put those on your graph. Okay, and then we also want to review graphing in vertex form. And vertex form is actually, I think, a lot easier because you have that 1 inside here, that's your H, and then your K is the number on the outside. So remember, this +1 means that I'm going to move left 1, and then the +2 means I move up 2, and that tells me my vertex, right? Anything inside the parentheses, I take the opposite of. So I'm going to take -1 and then +2. So my vertex is at left 1, up 2. I have a negative sign in front. My A value is negative, so that means I'm going to open downward. And I'm not stretched at all, so I'm just going to go down 1 and over 1, and then I'm going to go out 2 and down 4. Okay? All I wanted you guys to do with this part is just to practice graphing, because we want to make sure that we can graph these functions correctly. In order to solve systems, one of the easiest ways is actually to solve them by graphing. So if we can graph them, then we can figure out where they're going to intersect. Okay? So we have learned how to graph circles. We have reviewed how to graph quadratics. So now I'm going to ask you guys to think a little bit. If I take a circle and a quadratic and lines, we're familiar with lines, and I put them all on the same graph paper, okay? And my question to you is, how many solutions can these objects have? So literally, all I'm doing is picking up the circle, okay? And let's say I have a system where I have a line, oops, there's my green line, and the purple circle. I'm going to take the quadratic off, and I'm going to take the other line off. If I have a line and I have a circle, how many possible number of solutions could we have? Because right now, I see that they're intersecting 2 times. So I might have 2 solutions. Or if I take the line and I put it right here, then I might only have 1 solution. Or if I take the line and I move it completely away from the circle, well then it's not going to overlap at all, so I might have absolutely no solutions, right? So that would be a system of a circle and a line. So a system with a circle and line, and I'm going to say could have, I'm going to underline could because it depends on what the circle and line actually look like what's their equation. So a system with a circle and a line could have 1 solution, could have 2 solutions, or no solutions. Okay? And that was just because depending on where they're graphed, they might overlap once, they might overlap twice, they might not overlap at all. I'm going to move my line away, and I'm going to bring my quadratic into the picture. Okay, and I'll see if I can get rid of, let's delete these so that we can start over. Okay, so if I have a quadratic, let's say I put it right here. How many solutions would I have? Remember, a solution is where you have a point in common, so where they overlap. How many solutions would I have if I have a circle and a quadratic and they look like this? So I'm going to say a system with a circle and a quadratic. And again, I'm going to use the word could because we're not sure. It depends on the actual equation of them. But it could have, well, right now it looks like we could have 2. Because I see 2 places, right here and right here, where they'll overlap. So I could have 2. And then what if I move the parabola so it's sitting right on top of the circle, right? So then I would just have 1 solution because it's only hitting here 1 time. So what I'm going to ask you guys to think about is if you move this parabola, oops, if you pick up and move the parabola, how many solutions, how many different possibilities could you make? That's what our class is going to be about when I see you next time.